Okay, so given that material that is transported by rivers, it is going to change, as I was saying before, depending on the velocity of the stream. That's going to be the main driver, or if you think about it wider even, it's going to be based on the discharge of that stream. So depending on the discharge, which is a function of both the velocity and the area, which in turn is a function of the gradient, then the material that is transported throughout the longitudinal profile of that stream is going to change. So here's a representation. It's definitely not a great representation. It is, exaggerated, but it's a representation of the longitudinal profile of a stream. So this being its source up here, and then down here being its outlet, pretty much. So you're seeing that higher up, closer to the source, you have high gradient, right? So you're going to have high velocity, hence a pretty high discharge relative to like the area. So if the area was higher, it would be even greater discharge, but at least definitely a high velocity, high energy you're having. So because you have such high energy, you're going to be able to carry material that is very big, that is very coarse. So you're going to carry coarse gravels, for example. As you move further down into the longitudinal profile, you are decreasing the gradient. So you're carving through the bedrock and you're decreasing the gradient. The energy is a little bit smaller. You may be getting larger cross-sectional areas, but the velocity overall is decreasing. So you're getting less energy, less velocity, and with that you're also carrying smaller sediments. So you're no longer able to carry big sediments like cobbles and gravels, but now you're carrying maybe coarse sands and a little bit finer sands. As you move further down even into that longitudinal profile, you are now carrying things that are sand and silt and maybe even clay sized. Because you don't have nearly as much energy as you had before. Now the stream is pretty pleased with the gradient that it's at, so it's still flowing downhill, but it is now doing so much slower than it was before. It has much less energy. And then towards the end, like when it's closer to the outlet, to its base level, there's basically no gradient. There is no change in elevation here at the end. And so everything that was carried by the stream is simply deposited down. So for the most part, any sediment that reaches the outlet at no gradient is going to be clay sized. So very, very fine. Still like you're still are going to be able to touch it if you were to pick up a bunch of it at the bottom. But it's not going to be very visible, each particle by itself. So I talked a little bit about floodplain before, and depending on where the river is at which part of the longitudinal profile, you're going to get a larger floodplain, if at all, or a smaller one. So these two pictures are very good examples of floodplains. The one on the top, I believe, is in New Zealand, and you're seeing that the floodplain actually goes all the way to the edges of those mountains. So that's going to be the largest floodplain you have, say 1,000-year kind of floodplain, or maybe 500-year floodplain, meaning it's not very often that you're going to get that much water above the confinement of the channel. But if you do, the water can go all the way to the bottom of those mountains. The smaller floodplain, meaning the floodplain that perhaps happens every 100 years or every 10 years, is going to be this one that is visible right here. So this is going to be the confinement of one side, and this is going to be the confinement of the other side. So say that it's springtime and you're getting more water flowing through. That water level rises, say, 3 or 4 feet. It's hard to see in this picture, but let's say 3 or 4 feet. It's going to cover everything within this area right here. Okay, so that's going to be the floodplain for the 100-year flood, or again 10-year flood, and then this larger area is going to be a floodplain for maybe a 500 or 1,000-year flood, meaning it's going to be a very, very large event if that were to be the case. On the bottom image, as you're seeing it down here, this is actually an arroyo, so it's going to be a seasonal stream that only happens due to flash floods, pretty much, in southern Utah. Well, this picture is in southern Utah. But with arroyos, since they happen due to flash floods are going to be very, very high energy, and they're going to carry along with them a lot of sediment. So you're seeing that this is towards the end of the life of the arroyo, but you're seeing on the sides there's a bunch of sediment that has been deposited by previous years, or even by this same arroyo of this year. But it carries a lot of sediment with it, and again, it only happens seasonally. So the floodplain itself is going to be the extent at which you're seeing sediments deposited. So it looks like right here is the confinement for that for those flooding events. So it's going to be right there. And then you can't see the confinement for the other side, but all of this is still within that floodplain for that specific channel. So again, if I were to ask you on a quiz or an exam, the exact definition of a floodplain is going to be the land that is formed by a stream that stretches between and experiences flooding during high discharge of that channel. Okay? So now we're going to get a little bit into the different types of streams that you can have. And in order to do so, I'm going to define a few terms before we continue. So morphology is going to be the study of forms. Geomorphology is going to be the study of why landscapes look the way that they do. So in geology, there are many, many branches that you can take in your career. Geomorphology is one of them. So geomorphologists, for the most part, work with surface features, right? Because that is where landscapes are. And then there are certain geomorphologists that specialize in channel morphology, which is why streams look the way that they do. So we're going to go through a few types of streams and their specific morphology, their specific form. So pay attention well, because that's gonna determine a lot about the amount of sediment that is being eroded, transported, and deposited further downstream. Is going to have a lot to do with the channel morphology. Okay, so there are three main types of streams that we have. There's going to be the straight channel, which is kind of like the boring one, but we also have a braided channel and then a meandering channel. These rivers basically form in the particular form that they have, basically, based on the amount of sediment that they carry and whether they are seasonal or they are year-round channels, or the amount of water that they're carrying, basically. So the straight channel is going to be a mountainous channel for the most part. It is fairly uncommon, meaning it doesn't happen very often when a channel is straight. And of course, between all of these types of morphologies of channels, you can go from having a straight channel into a meandering channel into a braided channel, for example. So some channels most channels may start as being straight channels, straight streams, and then they become either meandering and braided as the gradient lowers. But again, straight channels are going to be mountainous. For the most part, they have a pretty high gradient, and because of that, they're very uncommon. If you were to take all the rivers in the world and subdivide them into straight, meandering, and braided, the straight channels would definitely occupy the lowest percentage of streams. But basically, the stream speed, the velocity, is going to vary between pools and riffles within the bed of that channel. So as you're seeing down here, pools are going to be kind of low points where the most amount of water is accumulated, and then riffles are going to be highest points within that stream. These pools are probably points of weakness in the bed of the stream, so it's easier for water to kind of carve through this area right here and then continue its flow across the channel. So for the most part, these pools and riffles happen in straight channels. They can happen in meandering channels as well, but they're very common in this straight channels. So the second type of channels that we have, again, are going to be meandering streams. So for meandering streams, as the name says, these rivers tend to take their time and just meander around. They're not going to a specific place really fast like the straight channels were, but rather they're taking their time, going through the landscape without any rush. So because of that, meandering streams tend to form where the gradient is lower. And because of that, they're going to have time to carve through and erode a lot, erode and deposit at the same time, depending on what part of the channel you're looking at. So meandering streams usually do have floodplains. Straight channels usually don't have floodplains. They're just that common narrow V-shape kind of cross-sectional area. So in the floodplains themselves, you're going to find different features like oxbow lakes, and I'll explain how they form in a second. But in the channel itself, you're going to have a few different parts. So you're also going to have pools and riffles like you had in the straight channels. The riffles are going to be kind of choke points, if you would. Not choke points, but points where there is neither erosion nor deposition happening on the sides of the channel, but rather there is erosion occurring on the bed. So not on the sides, the banks, but on the bed. And then after a riffle, there's usually going to be a cut bank. So this is going to be the cut bank side where the most erosion is occurring. So on this side, there's a lot of erosion because the velocity of the river is greatest on this side. And then on the other side of the channel, on the cross-sectional area, there's going to be the greatest amount of deposition because the velocity over here is going to be the lowest. So low velocity, you're going to get a lot of deposition at these point bars. And then high velocity, you're going to get a lot of erosion on this cut banks. It's what they're called. So after a cut bank point bar kind of feature, you're going to get another riffle and then a pool where you have, again, a cut bank on the high velocity side and a point bar on the low velocity side. So these oxbow lakes form by the meandering of the river itself. So assume that this river used to have a curve that used to go all the way around close to where the oxbow lake is right now. But it started seeing that it took a lot of energy for the water to go around that side and then make its path back into this top part over here. So probably a smaller channel within that stream started carving through over here, and eventually it decided to, all the water decided to go through that smaller channel it had started to carve because that was the channeler of less energy. Less energy had to be put into just simply going across over here than going all the way around there. So eventually the overall channel course changed, leaving a remain of water that was left behind, and that is now called an oxbow lake. All right, so you're going to find a bunch of them later on. So this example over here is of the Amazon River. So the Amazon River is a type of meandering channel. So you're seeing, for example, over here is a point bar, and over here is going to be the cut bank, right? So you're going to get a riffle right here, and then you're going to have a point bar over here, a cut bank over here. The pool is pretty much anything in between those two features, and then another riffle over here. You're also seeing that in this particular case, the stream has two different channels. So it has this very long and sinuous channel, and it has this smaller channel that is also a little bit sinuous, but not quite as long. So eventually what's going to happen is that the greatest amount of water is going to take the easier path, the smaller path, and this whole bit is going to become a great oxbow lake. And I'll show you some pictures of that later on, I believe. But again, this is the Amazon River. The Mississippi River also has that same meandering pattern that the Amazon River has.